So it is sometimes tedious and takes some time. Why don't we have the script language that can actually do the something operating system job? Okay, so monitoring and accounting and so on. So that is actually the main purpose of the Perl. So Perl can be used for the administrator a lot. So in other words, in your programming, the assignment, I think that you can use the Perl if you want. So Perl definitely. Somebody said the Python can be used for the part of operating system nowadays. And also, what if I want to develop the operating system? Do I need to kernel and everything? Sometimes it's not easy. So nowadays the emulator, there's the emulation. So it's so emulation can be used for the it's a kind of simulation. Okay. So one of the examples is Android application. So you don't have to have the real hardware. Instead, you can select the emulators, then it can pretend the Android device. Then you can implement the Android application. So the operating system, you can use such an emulator, even though you do not have the hardware, but you can test and compile, rebuild the kernel, and port your operating system to such as the simulation program emulation. Okay. So this is a summary of the example of the operating system. Those is not used a lot, but the single job operating system is used in many of the embedded operating system because it's a specific purpose. So embedded operating system is focusing on the specific the target and the specific purpose. So at the time it can be singular. But most of the general purpose of the operating system is the multitasking, like the Unix and the Windows system. And we will see what is the layered approach. So I already explained about the problem of the MS-DOS. MS-DOS is here that can control that is in charge of some part of the operating system, but a lot of the application of Windows is not connected to this one, which means that conflict a lot. Okay. So Unix system, start from in this case the Unix is the 69, and the commercial version started in 1970. Because of that, if you reset your battery of the computer, it will be January 1st, 1970. By the way, how does the computer calculate the date and time? So, motherboard, how does the motherboard? So actually, there is no way to know the time is the human perception. So then why is it 24 hours? What is a second? So we divide. In natural, there exists whatever, there can be time or whatever, there is a time, there exists time. But the human, for our convenience, we divide, so 1 year is 365 days, and 1 day is 24 hours, and divide, and so something like that. But it's a human perception, how the computer recognizes it. So computer has something, the signal clock. Okay, it's just a tick, 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 tick. It may be faster than that. Then they count such an electrical signal. Okay, for the 10 times, this is the 1 second. Then calculate the date and time. But there should be starting point. Otherwise, if you are using current time is changing, keep changing. So you should have a reasonable, not like the 100, 2,000 years ago, the 10,000 years ago, right? So, but not like the 10 years ago, because many of the applications start before that. So they decided 1970, January 1st as a study to calculate the date and time. So we will see the clock, the instruction, the later, how the computer calculate the generate the date and time. It's not very precise. So the computer time is not the millisecond level, but it divides, but it doesn't have to be such a precise, high precision. But so that's the reason most of the Unix systems started from the 69 or the 70. Okay, mostly the 70. The commercial version start the 70, but the 69 is the first one. So 69 is there are several very important things happen in the human history. I think the July something, Neil Armstrong landed on the moon. It was 69, right? And also Dr. E.F. Code in the database, he proposed a relational database model in 1969. Then his paper published in 1970. Then another important thing, the Professor Lee was born in 1969. Then the 1970 moved to another city. So it is 1969. There is the enhanced version. Then finally the upper the 1970 they divide into the two group of the Unix. One is the BSD. Another one is the SPR5. The BSD is used a lot nowadays currently. This is a very simplified version of the Unix history, but the details. So you can stay here. Okay. So this is the 69. It's kind of the family tree of the Unix system. It starts very simple, but as you can see, so it's the 69, the 81, and so on. You don't have to study this. I just print out and keep using every semester. So then, as you can see, there are many different. You can go back. And it's 2000, 2001, 2002, and hold on. Let's see. For example, this time, the 2004, there is the Darwin, the IRIS, and that IRIS is not. There's the Open BSD and so on, and also we can see from the 2005, 2006, the iOS and the Mac OS, the operating system, and the part of and the changing. So our Unix system is not developed at once. Many of sometimes open source, sometimes commercial, they rebuild and add and enhance. Then that will be the new version of the operating system. So this is the start of 2016. I'm going to add a couple of the last 2 years, but you can contribute. A lot of them are the open source is for specific purpose. So operating system, so it looks like just leave it. So operating system, it looks like everything is developed, then only the update the specific security. No. So every time, the moment there are new operating system coming up. That new operating system is not the really brand new. It's based on the existing one. By far, especially nowadays, the Unix and Linux system use the standard, like the POSIX standard, so IEEE standard. So it's also fun, but it is hard to find the experienced one. When I learned the computer first time, my supervisor, actually the mentor who hired me in the first job, he worked for the Hyundai. Hyundai is a car company, but actually the Hyundai has an electronic part. They developed a supercomputer a long time ago, but they quit such a service. So he worked for developing the operating system of the supercomputer at the time. So he knows the hardware and so on. So I learned from him actually, not from the classroom regarding to the operating system. Then if you have experience on the rebuild or the compile, you can actually join the community group to work on the new operating system or the new version or the testing. So then it will be really helpful to enhance the knowledge of the computer science as well as the computer engineering. So this is the Unix history. Don't try to memorize the Unix history. You don't have to. Okay. So, but It's just for your common sense. Okay. Then the Unix used, there are different approaches to build the kernel. One of them is the layered approach. There I'm going to introduce three different approaches to build the operating system kernel. First one is layered approach. Layered approach means first there is the hardware. This is nothing but hardware. There might be the embedded, like the device program, that is the firmware, which is not considered as the operating system. Some of them consider operating system, but this is layer 0. Then we can have the kernel moves that directly access or understand the standard of the hardware. So that is layer 1. And layer 2 is based on the layer 1. We can have another service like there is the layer 1 the module that can use the hard disk drive. Then based on that, I'd like to implement the file system. So outside the layer, and so on. The most outside the layer, obviously, it will be user interface. You would like to use the hardware, not directly through the user interface. Okay, so this is a layered approach. The benefit is a very flexible. Okay, you don't have to implement everything. So I'd like to implement something new algorithm for the CPU schedule. You can start here. So based on the lower layer. So I'm interested to develop the interface, so you can just focus on. So nowadays, when we build the Unix system, it's not brand new from A to Z. Instead, from the existing source code, you can add the library or the algorithm. Okay, so this is a layered approach. Obviously, the problem will be communication. So eventually, I'd like to use the hardware. You need to go through each layer, and the communication overhead will be the issues. So instead, if I have the system programming directly access this one, it will be faster. But due to the characteristics of the layered approach, is that there will be the overhead for the communication. Another structure of the operating system is the microkernel. Microkernel, the approach. Microkernel means so like it has a minimize, okay, minimize the functionality and the structure of the operating system. It doesn't consider the file system. It doesn't have the device program. Only the minimize, like the CPU and the memory that require that are needed to operate the kernel mode. Then that is called the microkernel. So for one of the example of the microkernel is the macOS, the kernel. macOS used it's called the Mahu. Mahu is the microkernel of the operating system. If you take a look at the macOS the structure, you can see they have so except the BSD, the standard structure, operating structure, is that the macOS adapt the BSD the part for example the BSD define the file system manipulation and so on. But the kernel mode part, it has its own, the minimize the kernel and combined with this one. That is the reason if you are familiar with the other Linux system, so you can just use the terminal, then use the Mac OS, just like as if you are using the Linux system. So that is the kernel, one of the kernel approach to keep the minimize the functionality structure of the operating system. Third one is the modular approach. Modular approach means not all of the structure of the operating system will be loaded into the memory when you start up your operating system. Instead, just the 1, 2, 3. So this is the minimum, the module. Then whenever you need, you can load, like the file system. I need to use the new file system, then the add to the memory, to add to the kernel. This is a modular approach. So let's use that approach, which means I need to purchase the module by module. For example, compiler. So when we purchased the Sun Microsystem was one of the cheapest server when 20 years ago. So they sell the product very cheap, but when I try to compile the C compile, So there is no the license. So I need to pay the separately and so on. So that is one of the reasons why some of the commercial operating system use a modular approach. So only the minimal part of the module will be loaded, and the others should be based on the purpose or based on payment. Nowadays they are combining some of the Mahu process and the modular approach and so on, which is called the hybrid approach. Then recently is quickly changing such operating system structure by considering the mobile device. Actually, the mobile device is the same as the other computer architecture. So not much different. It has a CPU, it has a memory, it has a storage. So actually, there's not much different. The main different thing is size. Think about the Raspberry Pi. Raspberry Pi is smaller than this. The size is not a big problem.
And user interface?
User interface, touch screen. The main problem in terms of computing architecture, main problem of the mobile device is power. Power consumption. So which means the battery. So even if the CPU is consume the most of the energy. So if you are investing to the Bitcoin, anyone? Or the GA? You are doing?
No, not
Still?
Yeah.
Are you set? You still have? So Bitcoin, there is how many? So 2 million. How many coins?
I think 14.
14. I think currently it's 14, but it's up to the 21.
Up to
Up to
20 something.
Yeah. So it will be actually we will get up to such a limited number of that. How? By running your computer. So it's P2P. So you can contribute some computation. Then as the reward of that participation, they will give sometimes the coin. At the time, the most so there are some site in China or Korea. So they put a lot of computer, then run the program, and then try to get such a coin as much as possible. The most important thing is temperature, because it's nothing but the computation. The CPU is running a lot, then the power. Sometimes the electric, the utility bill is higher than the money you got. So because the computer needs a lot of power, especially CPU. For example, several years ago, it's Samsung. The new Galaxy had a problem of the battery. Yes. Because they tried to minimize the battery, but the CPU, the capacity of the CPU needed more power. So at the time, there might be a problem. So by considering this one, the operating system architecture need to, for example, do they allow a lot of the service program? If you allow the service program or the background process is still running. So that consumes the CPU and that consumes the energy, the battery power. So first time, most of iOS and the Android, they prevent such a background process, which means it's a single tasking actually as a user interface. So if you change the application, so the current one will not be running like that. But nowadays, it's getting changed, the multitasking. But even the current multitasking is not like the Windows or the Linux, the multitasking. It's limited. Okay, so some of the application cannot be because it consumes a lot. So that is, other than that, actually it's very similar as the existing operating system. Okay, the iOS, and they have this is kind of the system library. The Kuka-Tachi, the Objective-C is used that, and the media service layer is because the cell phone, the most popular data type used created on the cell phone is the image and video. That is true. So because of this, they provide something graphic and audio and video. So dedicate the specialized layer of the operating system to process such a thing. Okay, and some other core operating. This is the same as the general operating system. Okay? The Android is the same thing. Android is pretty much similar, but such a power is always the issue. And if you can develop the new and the better capacity of the battery, I think that is the best way to be a billionaire. So still, currently, most of the companies they spend a lot of money. Especially later we will have the electronic car. In general, at the time the power is the battery is the most important part. So okay, so I'm going to quickly skip. This is the how to recreate the kernel, the first process. The other process we can create based on the system library later. Okay, in chapter 3 and 4 we will learn. But what about the kernel itself? Who created that kernel? So there is a specialized program like for example system, so that can create the kernel. Okay, that fit to the it's kind of the one set of the operating system. Okay, it's a virtual machine. Somebody said the output of the kernel revealed is called creating the kernel virtual machine. Then that image. Sometimes we call such a kernel as an image. So image will be just copied to the memory, then specific location, usually low address of the memory. Then it will start. Then it will create another process. So if you are interested, the textbook provided. Every semester I try to add this system, the exercise lab, but due to my laziness, I couldn't. But I practiced based on I tested based on the textbook. So if you see the textbook, there is the example to how to add a library or your own code by using the system, the program. So you can test it and review it. And then finally, such as the kernel, the virtual machine will be stored at somewhere in your partition, the persistent hard disk drive. Then your bootstrap or the BIOS program should know where is that the kernel. Okay. Sometimes such a kernel can be the Unix kernel, the Windows kernel, and some other operating system kernel. You may have the multiple operating system. At the time, we can use the program is in between the bootstrap and the such a kernel. In Linux, that is called the glog and or Lilo. I used the Lilo a long time ago. Or the anti-loader in the Windows. From time to time, if you accidentally or falsely stop your Windows, you can see some selection, whether save or save the Windows or the general Windows and something like that. There is the anti-loader program to load the specific kernel. Okay. So safe mode has the minimize. So it doesn't have the network connection. It will be the minimize kernel will be loaded and so on. However, nowadays we don't need such a thing. Why? Instead of considering multiple kernel, we start the primary operating system and create software level the virtual machine, like the VMware or the virtual dock, so we can create such a virtual machine. Okay, that's the end of the chapter 2. So the first 2 weeks we spent the overview of the computer architecture and the operating system structure. Then and also we talk about what we are going to learn throughout the semester, starting with the process management. So next week we will start with the process management, but we have the 15 minutes. As I announced today, I'm going to very briefly introduce what is the GCP that we are going to use throughout the semester. And today we are going to activate your GCP coupon. Then you are able to start to practice that. So. Okay, some the simple So, what is cloud computing? We are going to use the computing power, computer research, computing environment as a service. That's the idea of the cloud. So the traditional environment, the traditional approach when you are going to use the computing power in your business, what you guys need to do? Where do you store the data? First, you need to purchase the computer. Okay, so I paid 10,000. So I buy the computer. Then what is the next? You need to hire a person who knows how to deal with it. You can buy, but you don't know how to use it if you are not expert in it. Then anyway, configure, set up everything, then install the program that you need, or sometimes you need to purchase. You need to start the project to develop your application, then test and launch and maintain. And then if you need to monitor if your computer is not big enough, you need to buy the new one and keep the maintain or the managing the system. This is what's going on. Okay, in the traditional computer infrastructure, IT infrastructure. So there are several problems that you can imagine, like every time you need to maintain the cost. So also one of the interesting problem is the last class I gave the example of for example ticketing. So I do not know the current who is the celebrity, but I know the Justin Bieber. So for example, Justin Bieber, when Justin Bieber was popular, okay, so if he has a concert, so there is a website open, okay, then quickly it will be sold out. Then how many the transaction? So millions or not 100 million, but the millions of transaction at one time, okay. So to support such a millions of transactions within an hour, do I need to buy all the computer and network and everything? It will be cost. After the transaction, we don't need. So instead, if we can borrow, rent, and computer as a service, so we can pay only just an hour of usage, okay, and the number of transactions. So that is the idea of the computer. It's kind of renting the computer resource. So the reason why it's called the cloud, so there exists probably the data center and the computer stuff, CPU and the number of nodes. But their configuration is not fixed. So if we there are the 10 customers, their configuration will be changed for the 10 users. But the next day we have only 5 users, then we will be changed dynamically. So that is the idea of the cloud. Then give the bill based on the usage. So then as a user, we don't have to have such an infrastructure or so on, but just pay based on the usage. And for the cloud service side, they can maximize the utilization, and they can make more money. It looks like the 100 companies, the infrastructure, computer resource. So that is the idea of that cloud computing. As you know, the leading company in the cloud service nowadays is Amazon. So Amazon, the web services, AWS is the leading company. It is true. However, the main problem, it's not a problem, limitation of using the AWS in the classroom is the first, credit card. So just like the Amazon service, you need to first put the credit card. It can be charged every time. And also, for example, we use at UB, the AWS with the grant, but after the semester end, I forgot to delete my instances. Then I didn't realize whether it's paid. So every month is paid, the $30 is paid for the 6 months. Next semester I realized that, so like $200. billed and paid by the automatically. So also some of the international students do not have the credit card. It is true. So Google actually does not require the put the credit card when you start to use. Instead, if we have the Gmail account, there are $300 the free coupon, or they provide always every semester $50 the coupon for educational purpose. And also another thing is AWS. If you have a chance to log on the AWS, it's very simple. Just click, click, click. Then you can create some of the cluster supercomputer. So very simple. But you don't know what's going on behind. So as for the educational purpose, so I'd like to I want for students to have the more the low level. It's not low level processing or the hands-on exercise, but really you do better see what's going on the cloud computer side. So which means command line interface is better. So Google used really the command line interface for most of its service. So that's the reason I decided to use this one. So Google provide, so actually the Google worldwide, they have the data center in the Japan and Taiwan and Europe and North America and South America they have, and they are, as you can see, connected. Even they have their own backbone. Most of the company, they use, even the IT company, the telecommunication company, they pay the existing backbone. But the Google, they actually make their own backbone along the Atlantic Ocean and the Pacific Ocean. They have the money. Then they said it's almost real time. So we may not realize the latency between the location. That's the things. But Google has their own backbone. And you should be familiar with such a component of the Google Cloud Computing Platform. So one is compute. Computer means just computing power. Like I'd like to create the Unix machine, then you can use the compute engine. I'd like to create the Windows, the anti-server, you can use the compute engine. So it's a computer server as a service you can create. However, I'd like to create a web service, web application. So what you guys need to do is create the compute engine server and download the web server, install and configure and debug. It takes time, and sometimes you don't know how to do that. So App Engine provide the computer, including the installed application, web application. Like the web server is already installed. You can just select what kind of program language, Python, and what application server you use, the Django. Then if you click, then it will be, the web server will be created. That is called the app engine. So it's a platform as a service, the web application platform. So this one, compute engine, is infrastructure, the IT infrastructure. So this is the more specific, the service. So we are going to use the compute engine because our main purpose of this class is to understand the operating system. Especially we will use the Linux system, Debian, or the CentOS. Okay. Another interesting compute engine service is container engine. Container engine is like the